Hi students and friends, welcome to the channel Learn and Teach by Ayaz. So in this video, I'm going to talk about the formula, functional groups and terminology used in syllabus code 5070 and 0620. So let's start the lesson. Now here are some learning outcomes for this video lesson. State that a structural formula is an unambiguous description of the way the atoms in a molecule are arranged, including CH2 double bond CH2, CH3 CH2OH, CH3 COOCH3. Draw and interpret the displayed formula of a molecule to show all the atoms and all the bonds. Write and interpret general formula of the compounds in the same homologous series limited to alkanes CnH2n plus 2, alkenes CnH2n, alcohols CnH2n plus 1 OH, carboxylic acids CnH2n plus 1 COOH. A structure formula displays the atoms of the molecule in the order they are bonding. Now the structure formula, they are showing the order of the arrangement of atoms in a molecule. A structure formula consists of symbols for the atoms connected by short lines that represent chemical bonds like single covalent bonds, double covalent bonds, or triple covalent bonds. But here we are going to show only double covalent bonds. You have an example. If you look at the learning outcome, you can see the example. You have CH2 double bond CH2. This is structure formula of the compound ethene. Now second one, CH3 CH2OH. This is the structure formula of alcohol ethanol. In both of these, you see that only double bond is shown. In ethanol, there's no double bond. That's why I'm just straight away drawing the structure formula. Third example is of ester, which is CH3 COOCH3. This is an ester. The name of this ester is methyl ethanoate. The displayed formula is the one in which we use to show all the bonds between each atom. A dashed line represents the bond between atoms. For example, methane. Recall the molecular formula of methane. This is CH4. We have only one carbon atom. So I am going to show the carbon atom in the middle. And we have 4 hydrogen atoms bonded to this. One, two, three, 4. You see the dash line? These dash lines represent the bond between each atoms. Let's have some more examples of this displayed formula. For example, I want to draw the displayed formula of ethene. The molecular formula of ethene is C2H4. And I've just drawn the structure formula of ethene, which is CH2 double bond CH2. Now I'm going to draw the displayed formula of ethene. So I will draw like this: C double bond C, 1, 2, 3, 4. There are 4 hydrogen atoms bonded to 2 carbon atoms. Each carbon is bonded to 2 hydrogen atoms in this. So there are other examples also. We will see. Recall the general formula of alkanes, which is CnH2n plus 2. You can easily predict the molecular formula of alkanes using this general formula. What you have to do, just place the value of n here. For example, if n is 1, the formula will be C1 Don't need to write 1. 2 multiplied by 1 is 2. 2 plus 2 gives H4. CH4 will be the formula for the first member of alkanes, which is methane. Now, if you want to see more videos related to this, you can simply follow the video link shown below. Alkenes, the general formula for alkenes is CnH2n. First member starts with N2, not N1. The reason is that alkenes must have carbon-carbon double bond. Must have carbon-carbon double bond. There must be at least one carbon-carbon double bond. So the first member starts from N2. So molecular formula will be C2H4. The name is ethene. You can easily predict the molecular formula of other alkene members. What you have to do, just remember this CnH2n. Alternatively, you can watch the video using this link, so you'll find more details about this. Write and interpret general formula of compounds in the same homologous series limited to alcohols. Now alcohols we have CnH2n plus 2. Sorry, Cn we have CnH2n plus 1 OH as the general formula for alcohols. If the value of N is 1, the molecular formula will be C and 1 multiplied by 2 is 2, 2 plus 1 is 3, H3OH. This is methanol. Second member, if you put 2 for N, what you'll get? You'll get C2, 2 multiplied by 2 is 4, 4 plus 1, 5, H5OH. This is ethanol. In the same way, you can work out the molecular formula of third member. If the value of N is 3, we will get C3, H, 2 multiplied by 3 is 6, 6 plus 1 is 7, H7OH. The name for this alcohol is propanol. Now I want you to work out the molecular formula of fourth and fifth member of alcohols. Now carboxylic acid, the general formula for carboxylic acid is CnH2n plus 1 COOH. Interestingly, the first member starts with the value of N 0. So if you write or take N as 0, you don't have any carbon, first carbon. So for hydrogen, 2 multiplied by 0 is 0, 0 plus 1 is 1. So we have HCOOH. This will be the molecular formula of the first member of carboxylic acid. So molecular formula will be H2C2O2. The name will be as, sorry, the molecular formula will be CH2O2. As there is only one carbon atom, so you write methanoic acid. The name ends on oic acid. What about the second member? Here the value of N is 1. So if you write 1, you'll get C. H2 multiplied by 1 is 2, 2 plus 1 is 3, CH3, COOH. So the molecular formula will be C2H4O2. Here we have total number of 2 carbon atoms. So I will write ethanoic acid. Again, the name ends on oic acid. What about the third member? If you'll take C2, then you have N2, you have C2, 2 multiplied by 2 is 4, 4 plus 1 is 5, C2H5, COOH. So the molecular formula will be C3H6O2. The name will be propanoic acid. Now I want you to work out the molecular formula for the fourth and fifth member of carboxylic acids. Define structural isomers as compounds with the same molecular formula but different structural formula, including C4H10 as CH3, CH2, CH2, CH3, and CH3CH, CH3, CH3, and C4H8 as CH3, CH2, CH double bond CH2, and CH3, CH double bond CH, CH3. Identify a functional group as an atom or group of atoms that determine the chemical properties of a homologous series. Describe the general characteristics of a homologous series as having the same functional group, having the same general formula, differing from one member